Okay, good afternoon. It's 12 o'clock, so it is literally just into the afternoon. Thank you for joining us for this MMC webinar with Constructing Excellence. My name is James Lundlack. Just want to make, actually, it'd be good to know where you're based at the moment, where you're watching this webinar from. If anyone could share that, that'd be good to know. Andrew Carpenter, who's the CEO for CE Midlands and strategic advisor for Donaldson Timber System, would typically chair these events. However, he's unable to make it this week. So I just wanted to make his apologies and also thank Howard from CE for organising this and Abraham for sorting out the technology. The webinar is going to cover a presentation completed by John, who will introduce himself in a minute. Then there'll be a break at about 20 past 12, where we'll have a bit of a discussion between John and I, and then we'll reconvene with the rest of the presentation from John, and then wrap up with some questions. There's going to be a poll running throughout the presentation, or the webinar, sorry. So I'd really appreciate if you could fill that in for us, so we can get a sense of what people are thinking about MMC. And any questions that you have for us, please feel free to submit, but please submit them in the Q&A Slido app, and we can answer those either during the presentation if it makes sense, or we will answer your questions at the end. So what I'm going to do is I'm going to hand over to John to introduce himself. I'll introduce myself, and then we'll crack on with the presentation. Over to you, John.
Thank you. Thank you, James. Yeah, hi, good afternoon, everyone. Thank you for joining. John Smith, I am Technical Director here at Donaldson Timber Systems and board member of the Structural Timber Association, our trade association, and the structural timber business, covering timber frame SIPs and engineered timber structures. So welcome all. I saw a couple of questions. I think maybe one question about not getting audio, but I think given people are filling in the poll, can I just get someone just to check that people can hear us okay, yeah? Yeah, good, thank you. See a couple of thumbs up, excellent. Right, thank you. Right, so we've got a couple of polls running there in terms of who we have in the audience here. Maybe, Howard, if we can jump on just before we start, it'd be good to get a view. If we can maybe on slide, we'll jump onto the second question. It would be good to get a view from you all before we kick in, what your current view of MMC is and experience of MMC. I don't know if that's possible to jump onto the second round of questions. Yeah, good, thank you. So I'll give everyone just a couple of minutes. If you're on Slido, you've got to look at that. Just be good to understand where you are and what your view is in terms of if you have reservations or none at all. Somebody's answered with a good start. That's ideal. Right, so if that's running through Slido, I'll crack on with what we're going to talk about. Let's just check that's all. Everybody can see that presentation screen now?
Yeah.
Yeah, all good. Thank you, James. Excellent. Right. So yeah, welcome. Thanks for coming along. Very brief introduction to us and our business is Donaldson's. We are part of the Donaldson Group, which is a 165-year family-owned business, currently run by Andrew and Michael Donaldson, the 6th generation of the business. Primarily, we are a group of business based primarily for most of the period in Scotland. Started in 1860, importing timber into Tayport and Fife, and have grown over that period up to currently around 1,200 colleagues across the businesses, working at 44 sites across the UK, and 11 separate business models. We are in the timber frame part of it. I'll touch on a little bit more detail, but within the division, within the Donaldson Group, we have our off-site division, comprising our Donaldson Door Systems, are a joinery door set manufacturer, stair producer, based in Airdrie in central Scotland, servicing most of the builders in Scotland and North England with those components. Donaldson Timber Engineering, who've been around for a number of years as well, truss manufacturer and floor supplier for most of the national house builders and local and regional customers across the UK, working out of 9 branches from Buckhaven and Fife down to Exeter in the southwest and Ashford in the southeast and everywhere in between. And ourselves as Donaldson Timber Systems. We are a timber frame manufacturer, just entering now our 51st year of manufacturing timber frames. So I know we're talking about modern methods of construction, but we've been doing this for 50 years. So it's still off-site, but it's maybe not as, it's been on the go for a while. We've got 2 factories, one in West Hill and Aberdeen, where I am just now, and based, and we've got another factory in Whitney, just outside Oxford. And again, cover the UK with timber frame delivery, currently on sites in Inverness and all the way down in Falmouth and Cornwall at the moment. So truly covering the whole UK with timber frame manufacture. We have capacity to make currently about 9,000 timber frame units a year, depending on how complicated or how complex or how much type of timber frame we manufacture. And we're well through an investment to increase that capacity through productivity and improvements that I'll touch on in a minute. And as I said, nationwide coverage and basing also supply and install quite a lot. In England, we supply and install the frame on site. In Scotland, it's quite often a mixture of supply and install or supply only, where it's a more common build method, and our customers are quite happy to install it themselves on site. In terms of that investment, we have just completed in our Whitney factory a £10 million investment in the factory to industrialise the manufacture of closed panels is really where we've aimed this at. So we've invested in a robotic wall line for the manufacture of open and closed panels, really as I said, to industrialise the manufacture of closed panel timber frame and seen a real significant productivity boost in that through that industrialisation. But also we've invested in a floor line to manufacture floor cassettes, and also taking use of technology, so integrated laser assisted production. So really with an aim between the robots, the automated line, the laser projection, with the simple aim that we're getting close to as to taking away the need for tape measures and drawings in the factory floor. Because the productivity gain of people, if you're looking at a drawing or you're measuring something, you're not actually constructing it. So that's where we're starting to look and get to making as much productivity gains as we can through the business. So that's us as Donaldson's and a timber frame manufacturer. As I go through the 2 parts of this presentation, I'll talk a little bit more about timber frame for those who may not be as aware of what it is and how it fits in with MMC and getting the best out of off-site manufacture. So the first one I want to talk to is on MMC is the definitions of that. This has been on the go for a while, so apologies. A number of people in the call, I suspect, will be aware of these, but I think it's just worth running through the different types of modern methods of construction and off-site manufacture. So the MMC definition framework was published a number of years ago now, and is pretty much embedded there. And it really is a range of approaches from off-site manufacture, near-site manufacture, but also the other 2 categories at the end that we'll touch on around process improvements and use of technology to help drive improvements in productivity on site. So category 1 is, I think, probably what most people think about when they think about MMC is actually 3-dimensional primary structural systems. So volumetric, if you like, that is used across the country in various guises, but basically volumetric structural pods, if you want, that can be a range of the structural chassis, just of the structure. It can include internal fit out and cladding, or it can include a number of things like fully finished rooms and room assemblies like bathrooms, kitchens and the like. Commonly used across the country at the moment in the UK and high-rise buildings where it works well with a lot of repetition, hotel type buildings, repetitive type buildings. a bit of it in housing, not a huge amount in housing, and successfully been involved in housing, but there is an element of volumetric housing goes on as well. But that's category 1 MMC, which, as I say, is 3D volumetric. Category 2 is two-dimensional, so panelized systems. Now, again, for this includes any sort of panelized system, so it could be precast concrete, steel frame, light gauge steel, or in our perspective, timber frame. So I want to apologise for talking about the timber frame impact of that during this. So timber frame, prefabricated wall panels, floor cassettes, roof cassettes, that sort of thing, fit into category 2. And a bit like the 3D volumetric option, it comes in 2 different categories. So category 2A is just a primary basic structural shell. So what we have typically been doing in the timber frame industry for 50 plus years is an open panel stud wall timber frame that you see in the top image there. Timber stud work with a sheathing board and a breather membrane on the outside, insulated on site, windows fitted on site, etc. That's category 2A. Category 2B becoming more common. As I mentioned, we've invested heavily to drive the volume of this forward, is more advanced timber frame. So closed panel, that being a panel that's the same structural timber shell, it's still got timber stud work in it, but factory insulated and bolded on the internal face. So it's a closed panel with options for factory fitted windows, and also it goes as far as some suppliers putting on external cladding, internal conduits, and more finished walls. So that comes under the level of category 2B, but still very much panelised product. Category 3 is again structural systems, but non-systemised is the description of that. Typically, for a simple description, posted beam, so it includes things like screw piles, driven piles, prefabricated pile caps and ring beams, columns for post and beam type structures, prefabricated floor slabs for ground floors, integrated assemblies. Things like staircases would fit into that category, and also pre-assembled roof trusses. So like every house in the country, whether it's timber frame, whether it's masonry, typically will all have prefabricated roof trusses on them, spandrel panels, staircases. So there's an element of MMC in all forms of build. Category 4 is where it starts to get a little bit different as well. So category 4 is essentially 3D printing, for want of a simpler description, additive manufacturing. Basically based on either remote, site-based or final workforce-based printing of parts. So that's on-site, 3D printed concrete type things, or the assembly of 3D printed components that can go into the building. Would be under category 4. And then category 5 is the last of the off-site manufactured products, is non-structural assemblies. So category 5 would include things like the volumetric sub-assembly pods. So if you're building a non-category 1, 2 or 3 building, but using prefabricated bathroom pods, kitchen pods, things like M&E equipment, so prefabricated boiler cupboards, that sort of thing, that would all fit under category 5. But also some of the other assemblies, so things like prefabricated facades, roof cassettes that fit into a timber frame or a masonry build would be classed as category 5, when it's non-structural, but roof assemblies, roof cassettes, or floor cassettes if they include horizontal services and the like. And the most common one probably is door sets. So pre-hinged with ironmongery door sets that fit into houses, be that timber frame, masonry, light gauge steel, again would all be classed as category 5 in terms of pre-manufacture. Into category 6 now, which is less off-site manufacture but productivity gains. Category 6 includes things that are more traditional led, but site labour productivity or improvements. So that includes things like, large format wall products. Thin joint masonry would be an example of that. Prefabricated walls, brick slips, or even to the stage of simple things like modular pipework, flexible pipework, modular wiring, brick slip systems that can become partly prefabricated, can all go into the case of Category 6. And then finally, there's the technology element. Was a mixture of technology and site labor reduction techniques. So things like non-technical, but the use of standardized temporary works, modular scaffolds, certainly like insulated concrete framework and the like, exoskeleton physical augmentation for site workers. That sort of thing comes under Category 7. And the technology part of it around things like site worker augmentation. So, virtual reality, augmented reality, starting to see a lot of that more coming in now with various work streams. And also the use of BIM and BIM-connected lean manufacturing frameworks. So digitally enabling workforce planning and coordination of trades and stuff on site. That all comes under Category 7. So, 7 categories of off-site manufacture MMC products, and the sum of all those come into essentially what's measured as pre-manufactured value to give a view of how far a project is manufactured on-site and off-site. And that really is a measure of the amount of materials that are assembled off-site versus on-site, and the amount of labour that's consumed off-site or on-site. And one as a percentage of the total gives a score of pre-manufactured value. Without quoting exact figures, I think a typical 2-story house construction in the UK or England these days, using brick and block masonry construction, would have a pre-manufactured value of high 30, low 40%. And that's because they'll use things like the windows will be prefabricated, they're not assembled on site. Roof trusses, staircases, kitchen components, door sets, all those things go into a traditional build brick and block house on site that add to a lot of the off-site manufacture. That kind of level goes up. Open panel timber frame would typically be in the sort of mid to high 40%. Closed panel timber frame with windows and doors, that sort of thing that we would supply, generally would get up to and above 50 to 55%. That sort of trigger of 55% that was targeted from Homes England as a target to get to. So 55% achieved with a closed panel timber frame, factory fitted windows, finished floor cassettes, roofs assembled at roof at ground level and lifted. We'll typically get to that kind of target. And then up to the fully volumetric buildings, so the Category 1, typically up to 60 and mid to higher 60%. Never get to 100% because you're still going to have all the infrastructure works on site and site works with groundworks and drainage and everything else that goes with that and foundations. So the range, although 0 to 100%, the actual range of pre-manufactured value in construction, typically from high 30% to high 60% is a kind of range of different technologies that are currently used, especially in the house building industry. So to talk briefly then on timber frame and how that works, and then we'll take a break and do some more polls and take some questions and have a discussion. Just to talk through the process of building timber frame for those that might not be aware. Typically, we will start on site, our works will start on site with a preformed foundation. So any form of foundation, be that an in situ cast slab through to prefabricated floor slabs. Typically we'll have a floor slab in place. First thing we'll do is on site is we'll fit what we call a sole plate. So that's just basically taking the first setting out timber component that goes onto the slab. We'll come on site, we'll measure it out, we'll fit that plate to make sure it's absolutely level. The building is square and the right size, and that's the real first critical quality check to make sure that the prefabricated components that come from the factory are going to fit properly on the building on site. So that process will be done typically anything from a week or 2 weeks before the timber frame arrives to earlier to help setting out brickwork and external works. We'll then assemble the roof, so we'll deliver the roof first. And assemble the roof at ground level, so all the trusses, spandrel panels, bracing, lifting beams, etc. Typically what you would see in any common house building roof, but we do that at ground level. The benefit that gives us is it takes away the need for temporary works in terms of temporary working platforms, less working at height, and it gives us some real efficiencies with the use of the crane to build the product on site. So before the frame arrives, we will have the roof assembled. The next step is what we would call delivery day. So we would start on the day of the delivery of the frame, set a crane up outside the plot. The first thing we'll do in the morning is lift the pre-assembled roof out of the plot that it's going to go onto. We'll lift that out of the plot and put it outside the plot in front of the crane. The timber frame will then arrive, and then we go through the process of installing that timber frame element for that house or terrace of houses. And that will comprise of ground floor wall panels, as I said, can be category 2A, open panel timber frame, or closed panel in the image there with factory fitted windows. Prefabricated elements of the walls, they'll be offloaded from the delivery trailer straight into the plot and then installed vertically and braced and put into place. We'll go around the whole wall, do the external walls, load-bearing walls, party walls and structure. We'll then drop on first floor cassettes, again, preformed panels with a joist, finished chipboard flooring, can come with the option of, we'll always have the stairwell aperture formed, any trimming or holes for services pipes, and the option for fitting service pipes and the like into those cassettes. Repeat the process on a 2-storey house typically, is repeat the process for the first floor walls. We'll lift those up, put them into the slab and plot, and then stand them up vertically. And then the last element is to lift the completed roof back onto the plots. Again, with the option, ideally, commonly at the moment, it'll be a assembled truss roof, but can with the option of coordinate the trades, put things like felt and batten onto the roof before we lift it. So at the end of the day, that process, you've got essentially a category 2B timber frame. You've got external walls, factory fitted windows and doors, prefabricated floor cassettes, and a roof with felt and batten on. The completion of that process essentially gives you a weather-tight structure to start first internal works immediately. As I said at the start of this part of it, sole plate can be done weeks ahead to get it done. The roof is then delivered and assembled. Stage 3 there, where we start on site with the timber frame and the crane. From that starting stage 3 and lifting the roof out to lifting the roof back on, for a typical 4-bed detached pair of small 3-bed semi-detached units, that process is 1 day. So from slab to having the roof up and in situ and the crane off-site is a 1-day installation process. So that's where we get the real productivity gain compared to a masonry build construction, where that can be 8, 10, 12 weeks plus to get from slab to roof level. We've got a bit of work beforehand in terms of doing the sole plate and the assembled roof. But the day the frame arrives, we're building that whole thing up in 1 day. And the next bit we'll talk on to once we have a short break is how that impacts the pre-construction phase of the works and how to get the best out of MMC and make sure that we do get the real benefit of that time benefit. So at that point, we'll take a wee short break from the presentation. I'll invite James back in. And we'll have a look. We've got some stuff there on the poll. So good to see on there then that a few reservations around design flexibility. Good, we can talk about that. A bit on programmer procurement risk. Again, good, I'll touch on some of that. A little bit on warranty and mortgage concerns. We can pick that up certainly as well. But no major reservations is encouraging. That's a pretty high percentage there by the looks of it. So thank you all for filling that in. There are more polls that I think we've got actively running through on Slido if you want to do that. But James, is there anything you wanted to pick up at this point?
Yeah, firstly, I've got to introduce myself, so sorry about that all. My name's James Lunlack. I'm the Regional Manager for the South West and Quality Manager for Donaldson Timber System. And the chair for the Bristol hub of the CIOB. So yeah, that's me. The title of this webinar was how to get the best value from MMC. And so I thought it'd be interesting to hear from you, John, where you know, let's face it, MMC is not always well deployed and it can be exceptionally well deployed. So do you have any examples of where, I guess, timber frame, because that's our experience, it is well deployed and poorly deployed, and and the sort of reasons for both, which I think will be the same.
Yeah, no, okay, thank. I suppose, yeah. I mean, the real examples from our world, and again, we'll talk about this from our world, and I should have mentioned as part of the introduction to the group that we are primarily focused on sort of low-rise house building. So two and 3 story houses, 3-4 story apartment buildings. Yeah, we do an element of non-domestic buildings, small schools, hospitals, hotel, budget hotel type stuff. But if I talk about the housing industry first, because that's our core product, yeah, I suppose the extreme example of really good use of it is where we've got high volume standardized components and been involved early days. So, you know, a real life example probably with the extreme being MOD housing, but we about 6 years ago now, we did a project in conjunction with another timber frame manufacturer and Level Construction at Salisbury Plain, and basically involved in building 913 units for troops coming back from Germany at 3 sites in Salisbury Plain, all built in timber frame. But essentially what we did in there is we had a range of standardized components, but we were involved in the design of that house types in the range with the timber frame element and the MMC about 1.5 years before the building actually started, so we could really develop really efficient house types and really efficient designs. That whole program for 913 houses and across 3 different sites and projects from start to finish from a construction phase was 16 months. At one point on site at the site in Larkhill, just next to Stonehenge, we were building and constructing 16 plots a week consistently all the way through. So, you know, that is an extreme example of getting the benefit of speed of build and coordination and standardization. I think really works. Where we build timber frame and it doesn't go so well, I think if we can do it that way, it's typically where we get involved just far too late in the process. And I think that probably fits for all methods of MMC. We can pretty much build anything in timber frame. Any house design, any apartment design, it can be built in timber frame. But typically it's not very productive because there'll be elements that can't be made weather tight. It'll be pushing timber frame to its limits of design a lot of the time. So where we get invited to quote for a project and we're at RIB stage sort of 4, and we've got pretty much technical designs complete, or we're at manufacturing construction phase, at that point it's too late to influence a design. And yes, we can make it in timber frame. Typically we end up with it not producing the time or the commercial benefits that we'd expect it to, because we haven't had the influence to just make small tweaks and small changes. It's not whole heart changes that we need to make.
Yeah, I mean, that message comes across loud and clear. I think what I'm seeing in our industry is we early on in the development of a project, we're very much focused on the vernacular and getting it through planning, for instance, and then we start thinking about how we're going to build it. Whereas I think if people really want to adopt MMC and get the best out of it, you do need to be really considering how you're going to build it at those early stages. And the big difference, I think, with us and traditional design and build is that we are a manufacturer, and to benefit from the speed on site and the quality, all that detailing has to be done up front so that we can then manufacture. So interestingly, in Scotland, you guys are I think 90% of your construction output is in timber frame. Is that correct? Why do you think Scotland is so much further ahead as such?
I think one simple one. There's loads of debates about its availability of trees in Scotland and timber and clay and England to make bricks and blocks. There's a lot of discussion about weather. Reality, where we sit now and have for the last 10-20 years, the simple answer is it's habit. It's the way we've been building in Scotland now for a number of years. The trades are used to it. Design teams, contractors, house builders, follow-on trades on site. It's the common way of build, and it's not a change. We've also got, and evolved through that, we have a trade in Scotland that's a joiner that will do the majority of the house build. So typically we'll have a team of people on site under a joinery trade that will install the timber frame, they'll fit the windows, they'll felt and batten the roof, fit all the insulation, fit all the plasterboard, fit the kitchen, fit the stairs, do the second fix joinery, that same trade, as a multi-skilled trade, will do all that work, which basically means they can have, as a joinery company, they can have 3 or 4 people on a site who are 100% utilised and always on site working and building. They're not waiting for the preceding trade to start. They don't get delayed because, it's blowing a gale like it was last week, and the crane can't lift the timber frame. The guys aren't there, they've got downtime, they're inside sitting on site. So I think that habit and that evolution of the trades certainly is the biggest difference. We are seeing it growing in England. It's grown in England quite a lot in the last sort of 2, 3, 4 years. We've seen a significant shift. Most of the major house builders, national major house builders in England, have now got either invested in their own or in partnership with timber frame providers. So, Barrett with Oregon for 6 or 7 years now. We've had Cala purchasing timber frame, Taylor Lane timber frame, Taylor Wimpey, Bellway setting up their own factories. So there's a big investment in timber frame growing into the house building industry. That is growing, and it's again, the biggest barrier to that is understanding commerciality of timber frame and really getting that understood properly. And follow-on trades and just getting the trades to understand this subtle difference. Typically, in our view, once we've got timber frame on a site, it takes probably 6-9 months for the trades and the business to get used to it, and then it kind of flies. So there's no regulatory change. I don't think it's weather. I think it is just pure habit, and it's that change process that we're going through to get timber frame more understood in house building.
Are you aware of a recent BSI standard that came out, PAS 700 last year for modern methods of construction?
Yeah, I am. If I'm honest, I'm probably less aware. I think you probably are, James. So maybe I can throw that one back. If I think you've been through that and aware of it, I know where it's looking at how to get the benefits. So maybe you could give my lesson. You can take through it.
Much to my wife's dismay, I read it on my holiday in southern Italy. I don't know why I chose to do that, but nonetheless, it's quite a lengthy document, and it sort of came out last year, a bit under the radar. So it's PAS 8700 2025, modern methods of construction for new build residential properties. It's pretty lengthy. There's a lot in there, but the essence of it is to give clients or anybody who are looking to adopt MMC a structure and framework to go about doing that, what the roles are, how it differs from the typical standard processes are. For instance, it's introducing a role for, I think it's called modern MMC advisor. So you would reach out to an individual or company that can advise you on the different MMC approaches, whether it's volumetric, SIPs, or what we do that would best suit your project. And then you go through a process of obviously decision making, but then it does address in quite a lot of detail about the earlier engagement of your system provider, your technical development, and all of that. So I won't go through it any further than that, because it's a document that needs to be read. So I would suggest that anybody that is looking to adopt MMC and is not too sure which way to go, I think that's quite a good starting point, and it's free to download from BSI. We also have our own. We've invested quite heavily, haven't we, in Grasp? Do you want to give a bit in insight, John?
Yeah. So we've launched recently for those customers who do choose to work with us. We've launched a training program online. We've been doing a lot of training with our customers, and mostly, as I mentioned, partly with our customers up front, and the bit I'm going to talk about in the second part of the webinar here, in terms of getting ready for MMC and understanding it, but also a lot of time with their follow-on trades, making sure that the understanding can be the best. We can all, across the timber frame industry, manufacture and supply high quality timber frame buildings, but if the follow-on trades don't generally get and understand what's different about it, the end of the project can be difficult. So to turn that into it, we've invested in an online training tool called Grasp. 140 different modules of everything about timber frame, to high-level introduction to what timber frame is, to then detailed work plans for technical people and how to design for timber frame, commercial people and how to do the assessment of timber frame versus other forms of build, through to follow-on trades and how a bricklayer needs to work differently between timber frame and masonry build, or a dry liner needs to work differently. Really, as part of it's just to help when, as I say, when we build a timber frame, we go on site and it works, making sure that the follow-on trades understand that, and also that the builder has got themselves geared up, which is, as I say, is the bit I'm going to talk about, is how to get the best of it in early engagement and not avoiding downtime and inefficiencies on site.
Okay, thank you. So well done. We wrapped up exactly on time for the next section of the presentation. So there, everyone who's joined us, please send us questions over. I don't know whether it's just I can't see them on my phone, Abraham, or I'm missing something. But if we can send questions over, we'll address them at the end or during the presentation. Yeah, and also if you want to get in contact with us or want us to follow up with you, please drop us your contact details. So John, I hand over to you.
Super, thank you. Right, let me share again. There we go. Hopefully that's come up again. Yep.
Yep.
Right. So yeah, design for manufacture and assembly. I suppose there's a couple of points in here. James mentioned PAS 87000. There's another document that's worth if you've not seen that. Is RIBA published in 2016 and a second edition published 4 or 5 years ago now, 2021. Was the design for manufacture overlay onto the RIBA plan of work. Again, it's a free to download. It's on the RIBA website. When we send the link out, I've included a link at the bottom of the slide there. But really, it goes through some of the stuff I just talked about, explains the different MMC and the different categories, shows some case studies and different forms of creativity and quality stuff, talks about digitally, but it also talks about, more importantly, what designers and project teams need to do differently. Bits of practical advice. Talks about procurement. Somebody had a concern, or some people had a concern about procurement being a barrier and how to avoid that, and just what the future looks like. So again, a good bit of collateral there that's available if you're new to this or looking at it, is how to get involved. In terms of the focus of this webinar, then, in terms of how to get the best out of MMC, one of the slides in there that we've just kind of shamefully just cut and paste into here is essentially how when to engage and when the right time to engage different parties are in different forms of modern methods of construction. So reality is the blue parts of that element are really the kind of earliest or the recommended start time of when different trades should start. So if I look at category 2 timber frame, RIB stage 1, so properly at sort of preparation and briefing of the project, that's when you want to get your MMC advisor advised. Now, that can be, as a manufacturer, that's a role that we would do and advise on that in there. But you're really looking to engage early as possible to make sure that you've got your MMC advisor. Your architect's obviously going to be involved at that stage in terms of preparation and briefing for the design of the project. And all the way through to how long that engagement's going to last, all the way through to, to manufacturing and handover typically. So, that's in there. The pink line down the middle is typically for planning sets. I think a key line in there to take account of, doesn't quite jump out as much as you'd like it to, but in yellow, is design freeze, and actually understanding when we need to have a frozen design and decisions made. That's how we understand the difference in that from a masonry build, typical built house in the UK at the moment, is where that design freeze starts and finishes, and when you need to procure different materials. That's certainly vitally important to make sure that we get the benefit of it. So to feed that into how we would work, then ideally, as I say, the earlier we get involved, the better, so we can influence design. Typically, how we'd like to get involved with a project so we can add value is right from early doors, that RIB stage 1 and 2, concept design, black line drawings, where we can start to look at, the first thing we would do at that point is do an assessment of cost and an estimate and a quote and a tender for a project. But even before that, happy to look at the house types. We'll then typically take a look at that house types and see how do we implement timber frame. We'll look at things as simple as, the structure of the building, joist span directions, not to find just the optimum design for the timber frame, but think about drainage runs, ventilation runs, air source heat pump, pipe work. How do we get the joist span in the right direction to make the follow-on trades as simple as possible? Consideration of groundworks, and it may be simpler for the timber frame to add a load-bearing wall in, but understand the consequence of how that impacts foundations. But doing that work at that point to then help inform the design team to then move on to the next stage of drawings is where we get the benefit. So typically we would go through that process, as I say, of comments, suggestions, work with the design team, agree a schematic of how the building's going to go together. We would then prepare the structural engineering design to confirm things like loads on the foundations, so you can get your foundation designs done and check the ground conditions, and then work out all the structural walls, joist sizes, beam sizes, where rack and buttress stability type walls would be within the building. Provide all that information, so all of that can then work through at the same time we're agreeing, wall build-ups to achieve thermal performance, acoustic performance, and all the other criteria we need to achieve with. Feed that in, so when you come to do your work and assembly drawings and the architect's working on, or your house builder's working on your working drawings, they're already coordinated and done to suit timber frame, with the walls in the right position, the walls done in the right width. And we're not doing it at that stage and then going back to complete it. So by the time we get to technical design in stage 4, then we've got a coordinated set of designs that allows us then go into the manufacturing process and go through our process of manufacture. And doing the factory shop drawings, site assembly drawings, feeding that into our robotic line, so running through our 3-dimensional software to produce all our saw files linked into stock use in the factories, run the saws, and then all the links into the automated assembly lines to run the robots to assemble the panels, and also produce all the site assembly drawings. So that's the kind of typical timeline process. That can be anything from a sort of 4, 5, 6 week process. Ideally, we get started much earlier in the process, and we start away 12, 14, 18, however far ahead. Some projects we've worked on for a couple of years at really early concept stage and standard house type designs with house builders to really implement timber frame into the business before we actually start getting to the stage of design process. And I think that's typically demonstrated here. What we've tried to do here is kind of overlay in the RIBA stages of work. The light grey kind of curve is where we would like to get involved, and the height of that is where we can add value. As I say, right at early day 1, stage 1, we can look at how we can maximise the benefit of MMC and timber frame, or any MMC product would be the same essentially, and work within your design, work with your design team to see what works and what doesn't work. We'll be very clear on limitations. We won't do timber frame for projects where it's just bending it too far out of shape and it's just not economical. We'll recommend that to say, actually, it's probably better you build this out of something else. The darker grey element there is where we sometimes get involved, and I mentioned earlier to James' question of when it doesn't go well, is when we get a completed technical design and we get a tender in, somebody wants to build a timber frame, but we get sent masonry drawings with all the load bearing structure already set, all the working drawings are done. Can you convert that into timber frame? And I want to be on site in 8 weeks. The answer probably is yes, we can build that in timber frame and we can be on site in 8 weeks or whenever the time scale is. But we're not going to have the chance to influence and really value engineer that to find the optimum solution for the frame, for the foundations, for the follow-on trades, for all the other things that come with it, and implement some of the standardization stuff I'm going to talk about. So that's where we can build it in timber frame, but we don't get the opportunity to add the value at an earlier stage. And then the last bit I want to talk about was design and design constraints and standardization. Commonly, I think people hear standardization and think of rows and rows of houses and bland estates that are identical boxes. From our view, I don't think it needs to be that at all. But that can always help from a manufacturing process. It would be easier to make lots and lots of exactly identical repeat houses. However, we need to be able to build homes and create places and street scenes and stuff that people want to live in and invest in. But there's an awful lot we can do. Standardised components in a house, there's a potential for huge benefit. We were involved back in about 7 or 8 years ago now in a project called MCH. Was a consortium around the application of industrialised methods for the construction of houses. So really looking at industrialising housing. At the time, part of Stuart Milne Group, we included Stuart Milne, L&Q, London and Quadrant Housing Association, Barratt Homes, a few others. What we did, part of the process we did through that to look at it was we looked at a standardisation assessment. We took 93 of the most common houses across the 4 house builders. And across those 93 houses, one example, we had 91 different stair designs for 2-storey houses. Now, lots of very similar stairs, but even straight flights, but they were different widths, or they had a bullnose at the bottom, or they had a stair at both sides, or a stair at one side, different floor heights changing very subtly. But 91 different stairs to suit 93 house types, which means there's 91 designs, there's 91 setups, there's 91 programming of CNC machines to be done to manufacture each one of those stairs. With a bit of thought about it and a bit of design input, every one of those stairs could be manufactured from 5 standard components. So, you know, a standard straight flight of different lengths. You would then have a 3-part wind, a 4-part wind, a quarter landing, and a half landing. And that could manufacture every element of stair. So a slightly different approach to thinking, which is where we get involved early, is rather than making a stair fit the room that's left in the house after we've designed in the kitchen, the bathroom, the living room and the bedrooms, is actually start with that and put a sort of common stair size in with a bit of flexibility in there, but put a common stair size in and just adjust the other room sizes to suit, to use standardized components. Windows and doors was, again, very similar, the same 93 house types, without looking at window components. So not thinking about different window fenestrations and different colours and different materials, because that will always be done to suit planning and requirements. But there was 68 different window opening sizes, and all very close. You know, we had everything from, you know, a nominal 1200 by 1200 window that was 1190 by 1190 or 1195 by 1200, and, you know, all within really small tolerances, but 68 different window sizes, because it's not a common approach to do it. So different window manufacturers doing different things. We've got different lintels to accommodate, and different openings to form in the panels in the factory. Again, all leads to a loss in productivity, or a potential to improve productivity and utilisation both in the factory and on site. So, you know, there's loads of that. We can look at standardised bathrooms, standardised WCs, and standardised components. This slide is trying to show, essentially, these are all from a standard house builder house range. Every one of the images on there comes from a standard timber frame house type, for that house type that's built across the UK. What changes is the roof finish changes. The external cladding materials and colours can change from brickwork to stone to render to cladding. Window styles change, window colours change, but the window opening size remains the same, in the same place, in the same location. All of that done, as I say, with a standard structural frame inside it. So I suppose the point being that, you know, early engagement, and within the realms of what a system can do, standardized design absolutely doesn't need to be full design. A lot of those house types and the images on these sites are from award-winning sites in terms of placemaking and street scenes and design process, but 100% used from a standard core and a standard chassis, if you like, within the timber frame. And then the last point on that, on here, is also looking at things like plot depths. A key one for us in any offsite manufacturer is story heights. We work with majority of the national house builders, a lot of regional house builders, and local contractors, and the private and affordable sector. Every house builder, and I say that without over exaggerating, every house builder we work for has got a different story height for their buildings. 2-storey houses with a different floor to floor height and a different ceiling height, for various drivers that it suited masonry construction when they did it, or it's just a preference. Nominally, they've all got a 2.3, 2.4 metre ceiling height, and nominally they've all got something around a 2.7 floor to floor height. But because every house builder's got a different floor to floor height, every panel we make for each of that builders has a different size. The studs are a different size. Majority of the house builders that we work with have all got a ceiling height that's nominally 2.4, but less. So they're probably buying 2.4 sheets of plasterboard and cutting a bit off the bottom, and paying somebody to cut it off, and then paying somebody to put it in a skip, and paying somebody to take it away. If we just had a standard 2.4 ceiling height across the world, then standard components again would fit again, minimise downtime, minimise activity, minimising waste, increasing productivity on site. It just needs that input from early doors to incorporate that into it. And again, starts to get some real productivity benefits without the impact on the design of the house or the feel of the house or the look of the house. It just is thinking about standardised components within the elements of design. But we need to be involved early doors to start to implement some of these things. So with that in mind, it would be unapologetically to finish on a bit of a sales plug at the end of this as well for anybody interested. We've kind of taken all that thinking that we've been working on for years. We've developed our own standard house range and pattern book. So we've got a range of 22 houses across the UK. 16 of them are compliant in Scotland, and we've got a few others that work in Scotland, in England or Scotland. The majority of work UK-wide. It's a range ideally focused probably on the social housing, affordable housing sector. Various ranges of compliance with space standards, all compliant with various levels of M4 or housing for varying needs in Scotland, and all designed for future home standard compliance. But it's really getting to the stage of a range of house types that were designed. We're not a developer, we've no plans to be a developer, but for those who want to have sites and build really effective, well-designed, well-set out, affordable housing sites, simplify the design stage because they're all designed, and it gets the ultimate use of all that things I've talked about of getting the use and the benefit of timber frame in there as early as possible. So again, get in touch. Our contact details, I think we can share that when we share the webinar between myself and James, and our contact details within the business to start getting involved in those. So 10 minutes left. I'll stop talking if I can. Thank you very much all. Hopefully that was worthwhile. I will stop sharing my screen now and hand back over to you, James, to see if we've got any questions or anything from the floor that we want to pick up and answer.
Yeah, thank you for that, John. You've done all the talking. It's been excellent. It's always I always enjoy those presentations, and the stuff around standardization and trying to build some harmonization in the way we build. I think it is a no-brainer really, and we don't have to do it and build a utilitarian world of bland housing. I think we can. You're never going to have both, but we could certainly be better. And it's not only with us and the manufacturing. You only need to go to a building site and see the amount of waste and offcuts that are chucked into a skip, and then that has to be dealt with and thrown away and recycled, and you've got to segregate it and blah blah blah. So anything we can do to try and reduce the variables between building types would certainly make a difference. Not easy, I understand that, but I think it'd be good for everybody really. So we do have a couple of questions. So please, we've got another sort of 7 minutes, and then we will be wrapped up. So please drop any questions. I don't know, I haven't seen any in the Slido. I'm just checking now. No. Oh, I have got. And so one question we have from Gareth Evans: what would be your recommendation for a one-off custom build house if we wanted to use off-site timber framing?
Yeah, okay, good question. First recommendation would be to make sure that you use a Structural Timber Association, an STA member, to do that timber frame. Typically, I'll declare now that it's not a part of the market that we are typically involved in Donaldson's. We're not geared up to do that. There are a number of companies and members within the STA who that's their sole focus, and that's the guys you want to talk to wherever you are in the country. But if you go to the STA website, it's quite simply www.structuraltimberassociation.com. You'll find that quite quickly on Google. Go on the STA website, and if you search there's a member search website that gives you all the people who are in the self-build market. Get involved with them early doors. The sooner the possible, the better. If you've got an architect or a design, quite a lot of those businesses will actually have in-house design capability as well to help you with your architectural design. But yeah, main point is go through an STA member to make sure that you're going to get the guaranteed quality and support that you need. That's where timber frame probably is a pretty high volume market share. I think it's I'm kind of going a little bit from my memory a while ago, but probably well over 50% of self-build is done timber frame in the UK. Including in England, and people get the benefit of that, absolutely.
Okay, any other questions? I'm going to just share my email address if anybody does want to drop me an email after this. But are there any more questions or anything we haven't covered? Or STA website is .co.uk,
Thank you, Andrew.
not .com. Thank you, Andrew. Yeah, we've got another 5 minutes. We can wrap up now, but please feel free to. Is there anything you would like us to answer that we haven't covered off that the title of the webinar was indicating we would? I think in summary, from my point of view, and I know it's difficult from a design point of view because you've got the client to think about and planning and all these other challenges, but the earlier you can engage with your system provider, i.e. timber frame, volumetric, SIPs, whatever it may be, even if it's masonry, the better value you will get out of the supplier, the manufacturer, or us. I mean, ultimately, we just want to have a great result as well. So here we go. There's a question here. With the problem with bricklayers, etc., would you consider external brick slip as an additional offering?
Yeah. Yes, is the short and simple answer. Not something that we as Donaldson's would do, would we supply and install, but yeah, we've worked with a few projects using brick slips or other cladding options. We have fire safe solutions for that as well. I think that's a key thing to consider if not using an external masonry skin. In a brick slip or any cladding system, is make sure there's a fire safe solution. Again, unapologetically, make sure you're using a Structural Timber Association member for your timber frame elements, because that's part of our a key part of membership, is that you can only make sure that we're selling fire safe solutions. So yeah, no, brick slips, any cladding systems can be installed typically on site. There are a few members who will factory fit those. Typically, it's not in our plan at the moment. Short-term plan, never say never in the future. But yeah, absolutely. I think that's key, that we take wet trades and that sort of stuff and brick slips off site. I think there's a real option when you get to that level that we could really eliminate scaffold from a building. We can build timber frame without a scaffold, but the first thing we do is put a scaffold around it so we can put a roofer on site to fit tiles and build the brickwork. A key target of mine is to get to the stage that we can build without a scaffold. Because reality nowadays, I'm not a builder. I probably think scaffold on a typical detached house is probably about £4,000 or £5,000 of cost that adds no value at all to the end of the house. So all those things taken into effect is absolutely, and doing the cladding away from brickwork is a key option.
Thank you, John. We've got a couple more questions here. One from Stephen Fitzwilliam. Thanks for a great presentation. Thank you. Do you have any examples of flatted projects we could review? I'm assuming you mean flats.
Yeah, no, absolutely. If you want to contact James, just use his email. If you do that, we'll get in touch. We can find out what you're looking for. Yeah, we've built. We've done a huge amount of flats over the years. It was a core part of the market, I suppose, back in the 2000s, pre-recession. There was a huge amount of apartments being built that we've done. Less so now because of less apartments getting built, but we still do quite a lot of small 3-4 story apartment building. So happy to share something with that with you. Absolutely.
Brilliant. And we've got one last question here from Marcia Johnson. Do you guys only build the frame, or would you be involved in scheme as the main contractor, including M&E and external work, as well as fit out?
No, so we are purely a timber frame manufacturer and supplier. I'll say at this point, I'll never rule out being a developer as part of the Donaldson Group. But yeah, no short immediate plans with Marcia to do that. We would purely work as a subcontractor to manufacture and install the timber frame.
Okay. Thank you, John. Right, well, that brings us very nicely 1 minute to one, perfectly timed. So the practice, John, isn't it, that we with the use of multi-trade operatives on site, how does the impact on the requirements of CS cards?
CS cards. Yeah, okay. I'll confess, probably not my absolute world of expertise in terms of the on-site activities. Yeah, I think the answer to that one is, I know I'm going to turn that around. I'm probably not going to answer the question because I don't know. It's a short answer. I know we are doing a load of work as the association on timber frame installers as a new trade, and how relevant CSCS cards are still as a requirement on site. So let me take that one back if I can. If you want, I know it's anonymous. If you want to answer the question, then drop us a note and we can get you a more detailed answer. Apologies, it's kind of out with my world of expertise right now to answer what the impact of that is.
Right, I think that's it. Any more questions before everyone goes for their lunch? Well earned. There we go. One more. How do you determine the boundaries of a timber frame system's valid application through fire testing, and when does change become a new system?
Okay, I think I understand the basis of that one. Yeah, so typically, all our systems are fire tested. As I said, it's a mandatory part of being a member of the STA to have fire safe systems. Typically, if a system is fire tested through the STA website, we have a pattern book, and it gives you what's called the field of application that lets you know the things you can change in the system without negating the fire test approval. So that would be the first place to ask. Your timber frame supplier should be able to help you with that, where that sits. But there will be, as I say, a field of application. So we've tried to do the system testing of pattern book of common timber frame systems to say things like, here's a wall, it's got a mineral fibre insulation in it, it's got a PIR board on the inside that's got a specification of X, and it can be anything between X and Y width. To get a bit of flexibility, you can make the panels lower in height, you can make them bigger in width. So yeah, typically there's a fairly defined list within any fire tested system of what the field of application is, of how much you can change and when making a change becomes a new system. So typically things like adding additional layers of insulations or materials would typically change the fire performance, and or changing the stud type. So, changing from a solid timber stud to an eye stud, for example, for more insulated walls would definitely be a change. And any change to the core product being the plasterboard internally or the cladding externally would be a core change as well. So, but yeah, typically, as I say, there's a field of application within the fire test that lets you know when things can be changed or not.
Okay. I keep saying it's the last question. Just as I say that, another one comes up. So I think that's it. The people are slowly dropping off. Yeah. Okay, we'll wrap it up there. I want to say thank you for everyone for joining. Hope you can take something away from this. And thank you to CE Midlands, Andrew Carpenter, Howard Betts, and Abraham for sorting this out. And of course, John's amazing technical knowledge. So yeah, great. Thank you, everybody, and have a nice lunch.
Thank you all.
Cheers. Bye.